Hi folks, we are going to talk this time a little bit about tension. Now, tension is a force that is directed through some sort of a rope, chain, cable, or something similar to that. Anytime that you have a bunch of ropes that hold up something like the Golden Gate Bridge, or chains that are holding up a child's swing, or a string that's holding up your prized fish you just caught, that force directed through those ropes and cables is a tension. Because tension is a force, that we use force units. We use pounds, we use newtons when we are describing these things. Now, as we describe tension, if there is no slack in the line, then what that means is that the force is going to be the same at every point in the rope, chain, or cable. So, for example, these two persons are engaged in a tug of war. One person is pulling right, the other one is pulling left. And if you were asked what is the force right in front of the left-hand person's hand, that's going to be exactly the same force that's right in front of the right-hand person's hand. That's why we use ropes, chains, and cables, is because they can transmit force from place to place in a very, very convenient way. So we're going to talk through a couple crazy little examples here, but I want to give you a vocabulary of situations before you start attacking the math problems having to do with tension. First off, let's talk about a dead fish. So someone goes out fishing and they have a fish that's got a hook in his mouth, and here's our little fish. Now, if this fish is dead, poor little fishy, he's just sitting there. And my question is, what is going to be the tension in the string? Well, the tension in the string is going to be equal to the force of gravity, or the weight of the fish. This is a Newton's first law situation, and the forces up are going to equal the forces down, and the only thing pulling on this rope in the downward direction is weight, or force of gravity. Now, what if you have a live fish and you've got a fish on the end of the string and the fish is going, no, no, I do not want to be caught. So the tension up is going to be a combination of the weight of the fish plus any sort of force of a pull. So if you've got a fish that's fighting you and pulling on this string because he can, then the tension's going to go up, because the tension is going to be the sum of both the force of gravity plus that extra force of pull caused by the fish trying to get away. Let's say we've got a tow truck, and we have a truck that is towing a vehicle with some sort of a rope or cable between the two of them. Now, what's going on here is we're just going to look at the tension in the cable between the truck and the vehicle, and my question is, what is that tension going to be? So let's say the car has a mass of 1,500 kilograms. This is my 1,500 kilogram car. The force of friction acting on the car is 2,000 newtons. So there's a force backwards of 2,000 newtons. And the car is being accelerated forward at 1 meter per second squared. So what's actually the tension in that cable? Well, just like we normally deal with, we are going to have the forces on every object. So if we just talk about just the car, there's the tension in the rope pulling it forward, there's the friction force pulling it backwards, and if we call the forward motion as positive, backwards as negative, then the tension minus the force of friction, those are going to be my net forces in the horizontal direction. They are going to make my mass accelerate. So I want to know what that tension is. It's going to be the mass times acceleration plus the force of friction when I move it to the other side. So it's going to be my 1,500 kilogram vehicle, the acceleration rate of 1 meter per second squared, plus that force of friction, which we were told is an additional 2,000 newtons. So the total tension in this string is going to be that 3,500 newtons. This is pretty much the same situation as the fish situation, but instead of it being up and down, the situation we just looked at with the tow truck and the car is left and right, but the math is the same. All right, let's switch things up a little bit. Let's talk about a small child that's sitting on a swing. So if you have a little kid that's sitting on a swing, and here's our happy little child who's playing on the swing, and this person's sitting right in the middle of an old-fashioned board swing. I don't know if you've ever swung on one of those. We used to have one in the yard until Mary sat on it and broke it. And yeah, the string broke and I landed on my high knee. It was exciting. Anyhow, all of the weight of this child, the force of gravity, is going down. And this rope, we've got one rope, and this rope is attached to a tree limb up here, and the rope is going down underneath the board and then back up again. So we have one rope, but the rope has 2 points of support. Because this rope has 2 points of support, and we've put our child right exactly in the middle of this swing, what happens is half the weight is supported by this support and half the weight is supported by that point of support. So if the child weighs 50 pounds, how much is the tension in each rope? Well, the tension in each rope then would be 25 pounds. And the reason is because we've got one rope, 2 points of support, and some of the force is supported by both sides. All right, let's do another problem. Let's say one of these military souls is not just hanging by the rope like a dead fish. This person is actually accelerating up the rope. So I have got my person climbing a rope and having a good time doing it. And let's take a look at the forces. I want to know what's the tension in this rope. So force of gravity is down, plus the person is accelerating up the rope. So my question is, does the tension would equal the force of gravity if this person was just hanging there? Then the force down would equal the force up. But because this person is accelerating up the rope, there's an extra force that causes the acceleration. So the tension is going to be force of gravity plus that force of the pull or force of the acceleration. So the tension is going to be mass times acceleration of gravity plus mass times our rate of acceleration. So 80 kilograms times 9.8 meters per second squared plus our 80 kilogram soldier times the rate of acceleration of 0.3 meters per second squared is going to give me a total, and I think I got the answer already done someplace, 808 newtons, if I did my math correctly, for the whole thing. Now, some of the problems we're going to deal with tension are situations called static equilibrium. Now, does static mean moving or not moving? Right, static means not moving. Now, equilibrium means Newton's first law situation, and it means that the sum of the forces on an object happens to equal 0. You can have dynamic equilibrium where things are moving and the sum of the forces equals 0, and a classic example of that is a car on cruise control going down a highway. But we're concentrating right now on static equilibrium, a non-moving situation. So all of the forces tend to equal 0. And the sum of the forces in the x direction and the sum of the forces in the y direction are also going to equal 0. So we're going to do a really, really simple problem. Let's say I've got 2 intrepid souls that are going to be on a window washing rig. And there are 2 ropes, 2 separate ropes. Let's call this rope 1, and I want to know what the tension is in both ropes. So I'm going to call the rope on the right rope 2 and the rope on the left rope 1. The rigging itself weighs 500 pounds. The person on the left weighs 150 pounds. And the person on the right is a little bit larger and weighs 300 pounds. Now, if I say that the tension in rope 1 is 400 pounds upward, what's going to be the tension in rope 2? Well, this is pretty simple. If the sum of the forces happen to be equal to 0, what it basically means is all the forces up have to equal all the forces down. So my down forces are going to be 500 plus 150 plus 300, and if I add all those together, my down forces are 950 pounds. They're going to equal my up forces, which are T2 plus T1, 400 pounds. And so what is T2? T2 is going to be 900 minus 400, or 550 pounds. Now question, does it make sense that the tension in the right-hand rope is more than the tension in the left-hand rope? It does, but why? Yeah, because the heavier person happens to be standing on the right, so there's more weight supported by this rope than the other. Okay, that will do for some basic background. We're going to come back next time with some problems. See you then.